ready to go to the small ID. Okay, so here is one small cylinder. It's got a height of f of x. It's got a radius of x. And it's got a tiny thickness that's so small, it's just a tiny little change, which is our dx. When we open up that cylinder, it becomes like a straight piece of paper, just like I showed you. And the volume of that will be length times width times, length times height times its depth. We get 2 pi x times f of x dx, which is basically 2 pi times the radius times the height dx. And then we integrate along the x-axis from A to B. Visual tips on drawing a cylinder. Take any point on the curve. Draw the radius perpendicular to the axis of rotation. Drop the height to that point. So for example, if I wanted to do this shape wrapped around the y-axis, I take a point on my curve. This is the radius of my cylinder. So if I did the exact same thing on the other side, and draw an oval, then this is the height of my cylinder. I can imagine trying to redraw what I drew on the other side. And we would have these cylinders starting small and adding them paper thin all the way along. That would fill that whole shape. Instead of doing what we did before, would have been taking this same point here and using a washer. Right? If we did the washer method, we're adding washers from this y value up until that y value. And all of our equations would have to be x equals to do the washer method rotating this way. For the cylinders, we're starting with our paper thin cylinder starting here and going this way up until we get to this point. With the cylinders, our height is this green line, which is y equals, and you wouldn't have to rearrange the equation. So here's an example that this example, washer and disc method, would not work. Well, it could, but if you wanted to solve this, you would have to find this point as the maximum point. You would have to complete the square of that parabola to rearrange it into a form where you could square root both sides. And whereas it is possible, it wouldn't be as fun because it would take more work, right? Mathematicians, like, we like doing math, but we don't like doing math we don't have to. We like to be like, what's the most efficient way? And then we have fun doing it. But if we have to do it in an inefficient way, we're like, oh. But if someone said, are the answers the same? Oh, now I have to do both ways and I would like it. So yeah, it's kind of interesting. So there is my cylinder. The 2 pi I can pull out in front. The circumference will be 2 pi. That's where the x comes involved. The height is my function, dx, and I'm going from 0 to 3. I can multiply that x through. Is this an easy integral to do? Absolutely. Plug in your values, we get our answer. By the point I've got my answer in this question, If I was using the other method, I wouldn't have even been able to Google, how do I complete the square again? Right, because that's probably the stage we would be at. To find the vertex, I have to complete the square again. How do I do that? So it's really cool as another idea of how I could fill up this volume by adding a bunch of paper thin cylinders all the way through. Find the volume of the solid generated by revolving the region bounded by the graphs of x squared plus 2x, the x-axis, the line equals x equals 1 about the y-axis. So once again, I'm going to draw a picture of this. If I factor this out, can you see that you would get x times x plus 2, which tells me I have an x-intercept at 0 and an x-intercept at negative 2. I know this parabola opens up. So there's my f of x graph. The line x equals 1 is right here. And so this orange section is the section that's going to get rotated about the y-axis. If I had wanted to do the washer method, this would be my little radius. This would be my big radius. Wow. Yeah, that's all right. There's my washer. Problem with my washer method is I need both equations to be x equals, and f of x is not easy to get x equals. So again, on the exam, a question like this, it will always be easy to get both equations as x equals, because they will not want to make it difficult for people doing the washer method. Okay. So they might just give you x squared, because that you could square root both sides and get x equals easily. That would be possible on an exam. But on this one, it's going to make a lot more sense for us to do paper thin cylinders. I'll draw a paper thin, I'll pick a point here. There's my paper thin cylinder. Rotating around. I'm going to add up all of those paper thin cylinders. So I go 2 pi x. I can take the 2 pi out x. The height is my function. Multiplying this through and integrating is easy. Plug in your numbers. 1s and 0s are very nice. And we get 11 pi over 6. Find the volume of solid generated by revolving the region bounded by the graph f of x equals x squared, so that's in purple. G of x equals 12 minus x, that's in black. To the right of x equals 1, that's in blue. Around the y-axis. So I'm going to color code the section that's taken out here. Right? that part, it's a very interesting watermelon that's going to be made. That part is getting revolved around the y. Both of these would be easy to get x equals. I'm just going to, under the purple one, can you see that you could get x equals plus or minus the square root of y? Under the black one, in black, I could easily rearrange this to be x equals, oops. All right, move the x to the other side. Move my y to the other side. It's easy to get both of these as x equals. So if I wanted to do the disk method, I could. But do you see that you would have to do it in two different sections? You would have to do the section from here, 1, 1, up to 9, because in that section it's purple minus blue, big radius minus little radius. And then from 9 to 12, the big radius is black and the little radius is blue again. So if I was doing washer method, big radius minus little radius, I'd have to break it up into two sections. Not crazy hard, quite doable. I would probably say on the exam, if you feel like doing that, perfect. If I did paper thin cylinders, so now I'm going to pick a point on here in orange. There's my paper thin cylinder. My radius is going to be x minus 1. Because I'm going to start a little bit small. My height is going to be the black function minus the purple function. So I've got all my intersection points. I know that if I did cylinders, I would go from 1 to 3. And in doing the cylinders, I don't have to break this up into two different sections, because I can start at 1 and have that same idea of cylinder go all the way to 3. Actually, the radius of my cylinder, because it's wrapped around the y-axis, is just still x. We don't have to worry about the 1 there. The 1 is just where we're starting from. And my height is the black function minus the purple function. Distribute that, and we have an easy integral to figure out. Notation-wise, you'd still write the 2 pi out in front, put square brackets once you integrate, go from 1 to 3. Again, I'm going to save you some time. I know you can plug the numbers in. Does it make sense? You could do the same thing if you wanted to do cylinders over the x-axis. Except now your circumference involves y. Your height of your cylinder would now be g of y and dy. I'm going to, on the video, show the answers for the next one, but not give you time to write them down. Okay, so I'm not super worried. Everybody got the formula down? I think the visual here is nice. Okay, on this one, I'm going to start with cylinders small here and move my cylinders all the way from 0 to 3 on my y. It's not going to be easy to get x equals by itself. This would be one the cylinder method would have to work. So this will be on there. You can try this on your own and you can check out the video to see the answers, but I'm not going to give you enough time to write this down. See? That wasn't enough time, was it? Same thing with this one. Here we have two graphs. I'm not going to give you enough time to write it down. It's another cylindrical method. I will have the answers on the video. Perfectly fine. What I'm trying to do is give you more time to study for your exam. And in this last one, this last one, I'm not going to give you enough time to write it down, but we're going to just talk about, this would be a typical one on the exam where you would have the choice. We have the two graphs, and it's not hard to do big radius minus little radius. This would be a calculator question. They could do this to you. You would have to find your intersection points with your calculator. They're not pretty. What I would do is I would store the small one as A and the big one as B, and then when I go to type this integral into my calculator, I would just use A's and B's there. Again, don't write this down, just watch. Then you would have to do the one function minus the other function, and you get your answer from your calculator. This would be the washer method. Big radius minus small radius. Notice we have pi r squareds in both of those. Okay. Using the cylinder, now your cylinders are moving along the x-axis, so this is now your A, and this is your B. And now you would have to rearrange your equations as y equals. So notice before these were x equals equations, they set themselves up nicely to be in terms of y. If you wanted to use the shell method, you would have to rearrange these equations. Okay? This is a typical exam question because it was set up to do the washer method because they already had x equals. We get the exact same answer using the cylindrical shell.